Мэцхан уу манлагш нь байна. За бүгдээрээ Summer Adventures гэсэн хуваарийн дагуу явагдаж байгаа 5 дугаар ангийнхаа хичээлийг үргэлжлүүлье. За өнөөдөр day 2 get lesson 2. За сэдв болвол хിവэрэ байгаа parents гэсэн. За юу гэхээр зэрэг яг жагсаалт эсвэл загвар давтамжийн тухай байгаа. За өнөөдрийн хичээл маань болохоор зэрэг яг давтамжийнхаа эсвэл parent буюу энэ жагсаалтынхаа яг дүрмийг нь олж мэдэх нэ гэсэн үг. За бүгдээрээ эхнийхээ асуултыг харъя. The first number in the pattern is 4. За хамгийн эхний тоо маань болохоор зэрэг яг 4 гэсэн байна. Үнэн байна уу? За эхний тоо бол 4. The rule is to add 8. Okay. So тэгснээ яасан? Дөрөв нь ямар вэ гэдгийг хэлсэн байна. Дөрөв бол байгаа тоон дээр 8-ыг нэмээд явах нэ гэсэн үг. За 4 дээр нэмэх нь 8, 12 мөн үү? Мөн. 12 дээр нэмэх нь 8, 20. 20 дээр нэмэх нь 8, 28. За дараагийнх нь select the true statement гэсэн байна. За хоёр өгөгдсөн дараагийн энэ хоёр өгөгдсөн хэсэг дээр энд байна. Эхнийх нь and хоёр дахь нь гэсэн ийм сонголтуудаас аль нь үнэн бэ гэдгийг одоо олох нь. За өгдсөн жасаалтаа тоонууд дээр дүрмээ ашиглаад үтсэн чинь зөв байсан. За эхнийхээ statement-ийг уншаад үзье. All of the numbers in this pattern are multiples of 6. За энд байгаа бүх тоонууд маань 4, 12, 20, 28 маань multiples of 6 гэхээр зэрэг яг 6-гийн хүрдэнд байдаг тоонуудаа гэсэн. Өөрөөр хэлбэл 6-ад хуваагдана гэсэн үг. За энэ үнэн үү? 4-ыг 6-гаар хуваагаад бүтэн тоо гаргаж авахгүй. Тэгэхээр эхний энэ statement бол үнэн биш байна. За дараагийнх нь хоёр дахь statement. All of the numbers in this pattern are composite. So composite гэдэг маань ямар учиртай юм бэ? Composite гэдгийн нөгөө талд болвол яг бид нар prime гэсэн ухагтун явж байгаа. Prime тоонууд маань бол яг зөвхөн өөртөө эсвэл нэгээр хуваагддаг ийм тоонуудыг хэлж байгаа. За composite гэхээр prime биш бүх number буюу тоонуудыг буюу яг олон хуваагдагчтай тийм тоо юм аа гэсэн. За ингээд хоёр дахь statement үнэн байна. Alright. The first number in the pattern is 20. The rule is to add 10. Okay, add 10. Let's check them. They all are 10s. And 20 plus 10 is 30. 30 plus 10, 40. 40 plus 10 is 50. So the rule is true. Now the task is to select the true statement. Now let's go ahead and check the first statement. First statement here. It says all of the numbers in this pattern are divisible by 4. Okay, divisible meaning they can be divided, right? So we can check them one by one, divide them up, or you can think about your multiplication facts for 4. So 4 times 1 is 4, 4 times 2 is 8, and so on. Or, in other words, you need to check your skip counting by 4 list. So, while you're doing that, do we get the number 20? Yes. Do we get number 30? I don't remember that. So, 4 times 7 is 28, and 4 times 8 is 32. So, it skips right over 30. So, that means this statement is not true. Okay, so we can just choose the second one and move on, but you don't always get two options. So you need to make it a habit to check both answer options. All right, all of these numbers in this pattern are divisible by 5. So in жагсаалтанд байгаа бүх тоонууд маань 5-ад хуваагдана гэсэн. So all these numbers should be divided by 5s. So in a times table in 5, multiplication table, right? Your answers either end in 0 or 5. So all these numbers here, they all end in 0. So that means they all are divisible by 5. So second statement is true. Okay, the first number in the pattern is 20. The rule is to subtract 4. So 20 minus 4 is 16, 16 minus 4 is 12, and 12 minus 4 is 8. So that rule is applicable and it works. Now, we need to select the true statement. So let's check the first statement. And it says all of the numbers in this pattern are multiples of 2. So for any number to be multiples of 2, you're just looking if it is an even number or not. Even numbers are the numbers that end in 0, 2, 4, 6, and 8. And then they all are even numbers, which our list right here, they all are even numbers. So first statement is true. All right, second statement, let's check that. All of the numbers in this pattern are multiples of 8. So multiples of 8 meaning what? They all should be divided by 8. So we should be thinking about our multiplication table for 8. Now, we cannot divide 20. Our first number here. 20 divided by 8 is not going to yield a whole number. So therefore, this is not a true statement because it says all of the numbers, not some. Oh, I did not select. All right, the first number in the pattern is 64. The rule is to subtract 10. So if we are subtracting 10, our tens place should be decreasing by 1. So tens place here was 6, it is 5, it is 4, and 3. So they all decrease by 1. Then this rule applies and it works. All right, so let's go ahead check the statements. First statement, let's check the first statement. All of the numbers in the pattern is, all of the numbers in the pattern are divisible by 4. So again, divisible meaning they can be divided by 4. So in the 4's multiplication fact, you can check them all in one. Since it says all, you can just pick a number you're not really sure about. So let's see, it is 34. I'm pretty sure within the multiplication facts with the up to 12, we have 30 something there. But 4 times 4 is 16, 4 times 5 is 20, 4 times 6 is 24, 4 times 7 is 28, and then 4 times 8 is 32, and 4 times 9 is 36. So we skipped right over that 34. Therefore, this one is not a true statement. Okay, so because it says all numbers, and we just found out 34 cannot be divided by 4 and get about an answer that is a whole number. All right, second statement, the ones digit of each number in this pattern is 4. So it is true. They all have what? 4 in the ones place. So 4, right here. 4. So we have 64 has 4, 4, 4, 4. So they all have 4 in ones place. All right, the first number in the pattern is 6. The rule is to add 21. So 6 plus 21 is 27. 27 plus 21 is 48. 48 plus 21 is 69. So this rule checks. Each value gets what? 21 added. So let's go ahead. This is what the rule is, add 21. Okay. Now we need to select the true statement. So let's check this first statement. It says all of the numbers in this pattern are multiples of 6. So remember, when you're looking at multiples, you understand that you should be thinking these numbers, they all should be divided by or divisible by 6. So therefore, I should be thinking about my multiplication table for 6. So 6 can be divided by 6, yes. 27, however, that's an odd number and it cannot be divided by 6. So that is not a true statement. Now, second statement, it says the numbers in this pattern switch between even and odd. So it is true that's even and the 27 is odd, 48 is even, and 69 is odd. Okay, the first number in this pattern is 3. The rule is to multiply by 2. So every time it will be doubling in values. All right, so 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. So this rule checks. So rule is what? To multiply by 2. So now let's check the statement in order to select the true statement. First one, all of the numbers in this pattern are prime. So remember the prime number. Prime numbers are only divisible by themselves and not 1. So 3 can be divided by 1 and a 3. That's it. So 3 is a prime number. However, our second number here, number 6, 6 can be divided by 1, 6 can be divided by 2, 6 can be divided by 3, and 6. So more than just the number itself and number 1. So this is not a true statement. Now, second statement says all of the numbers in this pattern are divisible by 3. So you gotta simply just check, do we know that these numbers show up in multiplication facts for 3? So when you are skip counting by 3, it's what? 3 times 1 is 3. 3 times 2 is 6, yes. And 3 times 3 is 9. 3 times 4 is 12, yes. And 3 times 8 is 24. So yes, they all are divided or can be divided or divisible by 3. Okay. The first number in this pattern is 36. The rule is to subtract 3. So 36 minus 3 is 33. 33 minus 3 is 30. 30 minus 3 is 27. So this rule to subtract 3 works. Now let's go ahead, check the statements in order to select the true statement. The first one, it says all of the numbers in this pattern are multiples of 3. So multiples of 6. 6, when you think of 36, yes, that can be divided by 6, and the answer is 6. But 33, there is no 33 in a multiplication fact for 6. And in other words, we cannot divide 33 by 6 and get a whole number as a value. So that is not a true statement. All right, the second statement, it says the numbers in this pattern switch between even and odd. So is that true? Let's check. This is even, 33 is odd, 30 is even, and 27 is odd. So that seems to be true. All right, the first number in the pattern is 33. The rule is to add 3. So 13 plus 3 is 16. 16 plus 3 is 19. 19 plus 3 is 22. So this rule to add 3 works. Now we are going to check the statements. All of the numbers in this pattern are divisible by 3, meaning they all can be divided by 3. But from the first number here, it seems like it's not going to work because number 13 is a prime number, meaning 13 only can be divided by number 1 or itself, which is number 13. So it cannot be divided by 3. That's not a true statement. Okay, so second statement, let's check that. The number in this pattern switch between odd and even. Okay, is that true? 13 is odd, 16 is even, 19 is odd, and 22 is even. Yes, that is a true statement. Okay, the first number in the pattern is 84. The rule is to subtract 7. Okay, so we have 84 minus 7 is 77. 77 minus 7 is 70. 70 minus 7 is 63. So it is true that rule to subtract 7 works. So let's check the statements. First statement, all of the numbers in this pattern are even. So we can see that this is not a true statement because we see 77 and a 63 are odd numbers. Okay, so let's check the second statement. It says all of the numbers in this pattern are divisible by 7. So it is true that when you think of your multiplication fact for 7, we have 7 times 9 is 63, 7 times 10 is 70, 7 times 11 is 77, and 7 times 12 is 84. So this is a true statement. The first number in the pattern is 87. The rule is to subtract 15. Okay, so we have 87 minus 15, that is 72. 72 minus 15 is 57, and 57 minus 15 is 42. So this rule to subtract 15 each time, it works. So let's go ahead, check the statements. All of the numbers in this pattern are multiples of 3, meaning they all can be divided by 3. Okay, so 87 can be divided by 3, and we will get 29. So 87 can be divided by 3. 72 can be divided by 3, and we will get 24. 57 we can divide it by let's see, yes, we can divide it by 3, and we will get 19. So that's true. And 42 can be divided by 3, we will get 16. So it looks like this first statement is true statement. Nice. Let's check the second one. It says the ones digit of each number in this pattern is 7. So that is not true because first number, it has 87, which is ones digit is 7. Second number has 2 in its ones place, and the last number also has 2 in the last place. So that first statement is the true one. The first number in the pattern is 30. The rule is to add 12. So 30 plus 12 is 42. 42 plus 12 is 54. 54 plus 12 is 66. So that rule to add 12 each time works. So let's go ahead, check the statement. First statement says all of the numbers in this pattern are multiples of 5. So multiples of, that means what? These numbers, they all can be what? Should be divisible. In other words, they can be divided by 5. So in the multiplication fact for 5, all the values end either in 0 or 5. And then we see numbers that are ending in 2 and 4 and 6. So this is not a true statement. Okay, so let's check the second statement. All of the numbers in this pattern are multiples of 6. So meaning these numbers, they all can be divided by 6. So 30 divided by 6 will be 5. 42 divided by 6 will be 7. 54 divided by 6 will be 9. And the 66 divided by 6 will be 11. So that last statement is true. Alright, the first number in the pattern is 27. The rule is to add 3. So 27 plus 3 is 30. 30 plus 3 is 33. 33 plus 3 is 36. So that rule to add 3 each time works. So let's go ahead and check the first statement. All of the numbers in this pattern are odd. So that is not true because 30 ends in 0. 36 ends in 6. So odd numbers cannot be ending in those numbers, and that is not a true statement. Second statement, all of the numbers in this pattern are divisible by 3. What does that mean? That means each number in this pattern can be divided by 3. So 27 divided by 3 will be 9. 30 divided by 3 is 10. 33 is what? 11. 36 divided by 3 is 12. So that second statement is true. Now we are entering the challenge zone. The first number in this pattern is 94. The rule is to subtract 5. So 94 minus 5 is 89. 89 minus 5 is 84. 84 minus 5 is 79. So this rule to subtract 5 each time, it works. So let's go ahead and check the statement. First one, all of the numbers in this pattern are even. So remember, even numbers, they either end in 0 or 2 or 4 or 6 or 8. And then we got numbers like 89 and 79. Then that means what? It is not a list of even numbers. So why do we know that, or how do we know that? Is what the ones place. So let's go ahead and check the second statement. It says the ones digits of the numbers in this pattern switch between 4 and 9. So it is true. We can tell what it is switching between 4 and 9. So it is 4, 9, 4, and 9. Okay, so that second statement is true. The first number in this pattern is 6. The rule is to multiply by 2. So 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. So each time they do double in value, meaning multiply by 2. So let's go ahead, check this statement. First statement, all of the numbers in this pattern are multiples of 3. So can they all be divided by 3? Yes. 6 divided by 3 is 2. 12 divided by 3 is 4. 24 divided by 3 is 8. And 48 divided by 3 is 16. So that first statement is true. Now let's check the second one. The numbers in this pattern switch between even and odd. But that doesn't seem to be true because what? Even numbers, they're supposed to end either 0, 2, 4, or 6, or 8. And they all are what? Ending in these numbers. That makes them all even numbers. So they're not switching. So that true statement is only the first one. All right, that is it.